Hello. Be forewarned that the audio of this video is really bad. I didn't realize that I had a bad audio cable until I was finished with the filming of the video. And it's really late here right now. It's almost 2 a.m. and I don't feel like redoing the video. So if you have headphones, you might want to turn them down until you hear the bad connection in the audio to see at what level you might want to set. The audio drops in and out and then... Greetings from northern Minnesota. George Notchik here. Today is Monday, July 29th, 2019, and I'm back in the saddle. I'm going to start making more videos after a long hiatus, resting up, but I was working on many problems, getting ready for the next series of videos. I have a lot of videos to do. I have yet to finish up with my videos on Coriolis forces, trajectories, my barrel curvature test this past winter out on the ice. I need to finish that up, plus the curvature measurements that I made the prior winter, more electromagnetics problems, Maxwell's equations, operational amplifier problems, electrical circuit problems, design of a high-end digital multimeter that I was involved with at Hewlett Packard. There's a long list of videos I've yet to make, and this will be the start. However, this video is going to be a little different. I'm starting off with a challenge to my viewers. Some proponents of the electric universe have been insisting that I look at a particular paper that was submitted a number of years ago to the Galilean Electrodynamics journal, which is a, I guess, lack of a better word, off-color journal that doesn't subscribe to mainstream science and provides a platform or a soapbox for people that have alternate theories of gravitation, special relativity, general relativity. It provides a journal by which they can submit papers. And what I'm going to do here is there's this one paper in particular that was submitted by a Morton Spears, or posthumously by his daughter, this paper that he wrote. And this paper is involving deriving the value for big G, that is the universal gravitational constant, big G, which is 6.674 times 10 to the minus 11th. That's the big G that you find in Newton's equation of gravitation. That is that force is equal to big G times the product of two masses divided by the distance between the center of masses of the two masses squared. And then this is also in vector form, where the vector force is in the AR direction, which is the radial line that connects the center of masses. Well, big G here has a value of 6.674 times 10 to the minus 11th, and the units on it would be kilograms squared, meters squared, newtons. So that when it's here, you're multiplying by kilograms squared, takes that out, times meters squared, and then you end up with newtons force. So that's the universal gravitational constant that we call big G. Now, in this paper here that Mr. Spears submitted to the Galilean Electrodynamics journal, derives this big G from purely electrostatic values. And the claim is because he was able to do that, that gravitational forces must be electrical in nature, and not a separate force or separate entity from electromagnetism. And that, of course, is just bollocks. That is not the case. The field of gravity, the forces, the gravitational forces, are indeed a separate force from electromagnetic forces. But this paper claims otherwise. Now, the paper is 9 pages. I'm only showing you the first 4 pages. This is on page 23, 24, 25, 26. I'll zoom in on this here in a bit so that you can see what's going on. And in the comment section of this video, I'm going to post links to this paper so you can pull it up as a PDF. And then there's also 2 books that Mr. Spears had written that deals with capacitances and gravity. What he's doing is he's linking gravitational force field to forces that are existing in capacitors, where you have capacitance between structures. For example, if I have some sort of geometry here, it could be spherical, it could be a cube, triangle, some sort of parallelepiped or whatever. But if we have a place plus charge on, say, that one, and minus charge on that one, then there'll be an electric field that exists between these 2 structures. And capacitance, if you remember, is just the definition of Q divided by the voltage between the 2 structures. Well, if you have an electric field, the the integral of E dot dl going from some initial point to some final point. And so if you integrate the electric field, you dot the electric field with your path differential, and you integrate from the minus Q to the plus Q to get the voltage. This would be, say, call this structure A, this structure B. So the structure between A and B, the voltage difference would be just the integration of your electric field over some path that you go between the 2 structures. And once you calculate that voltage will be a function of the charge Q. Quantity we call capacitance. So, in this paper, he makes use of the capacitances between 2 spherical objects. In some cases, like the capacitance between 2 electrons, the radius of the 2 structures are the same. They're 2 spherical objects that are using the classical radius of an electron, which is on the order of 10 to the minus 15th meters. And then there's other structures. For example, if you have 2 spheres, say this is of radius A, this is of radius B, and we have some separation D between them, then there's going to be a capacitance that we can calculate between these 2. That looks no good. So there'll be a and I have done this in another video, and you will need the information from that video in order to solve the problem that I'm going to give you. It's the video also in my pinned comment. Not only will I give you links to these papers, the books, I'll give you the link to that video, and you can watch my video. It's about a 15-20 minute video on calculating the capacitance between two spheres of different radii. Now, here's the check. This paper has some rather critical flaws that I found. And I'm going to ask you to find this. This is for you that are studying electromagnetics. You should be able to do this without having anything more than undergraduate first term electrostatics will be sufficient for you to find the errors. Now, there's 4 significant errors that I've identified, and you can find them on the first 4 pages. That's why I'm posting the pages here. The first 4 pages is basically kind of a summary of the rest of the body, the other 5 pages that go along with this. And then there's also some references to the book, one of the books that Mr. Spears wrote regarding this problem. Those books cover it in more details. This paper is 23, 24, 25, 26, you can find the 4 errors that I'm talking about. So your challenge is to find the errors that now I will give you 12 days. Today is the 29th, and on the 10th of August I will produce another video that will tell you where the errors are. And then another probably 5 days after that, I'll produce my final video, the 3rd video, that will give my analysis and show you all the errors and tell you why those are errors and what the correct equation should be and why the conclusions of this particular paper are wrong. So I'll do a thorough analysis. I'll show you where Mr. Spears went wrong. Well, it's hard to say that minor errors because they're rather significant actually. So the 4 errors I'll go over, and particularly the one major flaw that's a real showstopper for this paper. So again, your challenge is find the errors, or at least find one error, and post it to this video. And if you have the error right, I will write back to you and tell you that you properly identified the error, and then I'll point you in the direction for the other errors. So I'll zoom in now on these 4 pages so you can see to make sure you're getting the right document. And what's also interesting and is if you look at the date, I'll zoom in up here. This is the March-April 2010 issue. So I'm kind of wondering if this just isn't an April Fool's joke. Sometimes this is what happens. You find in professional journals, people will post on the March-April journal some bogus analysis, you know, as a joke, a bogus paper, and the reviewers will let it go through because, you know, this is what professionals do. They like to sometimes, you know, try to add a little bit of humor into their discipline. And this might be just that. I don't know. A lot of people in the electric universe are really taking this paper serious, but like I say, it has some fatal flaws. And your challenge is to find those errors. So I'll now zoom in on here so that you can see what the pages are. Okay, here's the first page of the paper. You can see the title is an electrostatic solution for gravity, for the gravity force and the value of big G. This is the journal Galilean Electrodynamics, and we can see that this is the March-April 2010 issue. Again, I'm wondering if this just might not be a April's Fool's joke. But here's the author, Morton Spears, and here is the abstract. I'll focus on this a bit if you want to read that. Oops. And I'll zoom over the first page so you can make sure that you identify the proper link, that you're getting the right paper. Here's the introduction. Now this diagram, what this is a diagram showing two hydrogen atoms. The two red objects, I colored this. The yellow is emphasizing some capacitance values. You look at it here, or the charges. We can see that this QE minus, that represents an electron. The QP plus, this is the nucleus of the hydrogen atom. And so we have two hydrogen atoms. The two nuclei are shown in red. I put them in red. And then there's the respective electrons. This nucleus here has this electron orbiting it, and this nucleus here in red has this electron orbiting it. And then there's respective capacitances that Mr. Spears has chosen that exist between the electrons, the two electrons here. We see capacitance C12 is the capacitance between electron 1 and electron 2, and then there's capacitances between the nucleus of one to the electron of the other, and so forth. And then these two capacitors here represent capacitances from the electron and the nucleus out towards infinity to a just a reference way out in deep space. This represents the isolated capacitance of an isolated sphere in space. So that's basically the diagram that Spears references. So I help you along here by explaining some of it to you. And then he has a set of definitions in here, his nomenclature, how he defines his variables. Unfortunately, in this paper, he does not number the equations. So if you're going to refer in your answer to me a particular equation, you're just going to have to identify on which page it's on and about at what line it's on. This is very poorly done. Typically in any professional paper you would number your equations or number the lines so you can refer people to a particular given equation. Here you can see I have a little bit of highlighting on my paper here that just to identify these forces that he's talking about. And I've written down here the actual value for G. The accepted value for big G as we know it today is 6.674301 with an uncertainty in the last two digits, times 10 to the minus 11. That is, we know the value of big G to about 1 part in 44,000, or to within 22 parts per million. And this is a value that Mr. Spears derives using electrostatic values. Now he's comparing his value to the currently accepted value, and at that time the current accepted value is different from what we accept today, and I'm referring everything to the value that I have in red, which is a current accepted value, and you can see that his currently accepted value is low by, or actually high. It's 6.68541, and the accepted value, the most precisely known value, measured value for big G is 6.6743. So he's comparing to this value. It doesn't make any difference, but the big problem here that should put a red flag to anybody is that here Spears' electrostatic unit calculation comes out to 6.68541, which is considerably off the accepted value. It's off by a couple tenths of a percent. And that should be an immediate red flag. I mean, if you're deriving things from first principles, you should come right on to the value within the accepted value with much better precision than that. You should be well within the measurement error of 22 parts per million. He's off by quite a bit, and that should have just been a red flag right there. But so anyway, again, try to find the errors in the paper. That's the second page. Here's the third page, page 25. You can see that there's some equations here. And page 26. So those 4 pages is what you need to focus on to find the errors. You need to read the whole document, though, all 9 pages, to get the flavor for what he's doing. So again, post your answers to the comment section of this video. The errors that you think exist in the paper, particularly the fatal flaws, post them in the comment section here. And again, I will make a second video 12 days from now pointing out the errors, and then given that information, if you haven't figured out what the errors are, after I identify them for you, then you can go and see how to fix it or why those are errors, and then I will post by the end of August. Let's see, I'll be posting on the 10th the second video, so on the 15th, the middle of August, I will post the solutions and point out and go into detail why the errors that I found are indeed errors and where Mr. Spears went wrong. So, good luck. Happy posting.